So this is the Venture XL by Fysetc. It is based on the belted gantry design of the VORON 2.4 and it is huge. It offers over 8 times the build volume of a standard 400 by 400mm VORON. It is so big that smaller 3D printers like VORON 0 look like ants. However, designing a large 3D printer isn't the hard part. The challenge is making one that prints well with no issues, as so many things become complicated when we scale up. But as the Venture XL is based on the solid VORON 2.4 design, uses CNC'd aluminum parts for the motion system, and has hefty 40 by 40mm extrusions for the frame, I have high hopes. But is it actually good? And what on earth would you even print with something this massive? Well, let's find out. The Venture XL kit arrived in 3 boxes, all neatly and securely packed with soft foam. What surprised me the most was that a lot of the wiring was already done, and I didn't have to flash or install anything to get the printer going. It comes with 2 genuine minimal power supplies. The 24V PSU powers the main electronics and the Z-axis motors, which have a high 27:1 gearing ratio to prevent the gantry from dropping when the motors are off. The 48V PSU powers the AB motors, enabling speeds up to 700mm per second and accelerations of 40,000mm per second squared. The high numbers don't stop there, it also has the biggest PII sheet I have ever seen, 600 by 600mm that goes onto 4 bed assemblies. Realistically, the print height goes to around 550mm, but we need some sort of PTFE tube tensioning solution to prevent it from sagging on tall prints. So while the kit seemed very promising, there were also some questionable choices. The included hot end just doesn't have enough flow rate for a printer with this kind of volume. Fysetc seems to be aware, as they mentioned they are working with Fysetc to offer the Rapido 2 hot end as an upgrade. It was also disappointing to see the printed parts made from PTG, which VORON team specifically advises against. PTG just doesn't handle heat like ABS or ASE, which I show here with a part from a kit in the Sunlu E2 dryer at 90°C temperature. I won't go into all the build details, but rather make a summary. For all the issues I encountered, there will be a Patreon post, which is open to everyone. The build shouldn't have been difficult, aside from the tight space I was working in, but it kinda was, mainly due to poor instructions and a few missing parts. As one example, the instructions say to wire the Z motors very early in the build, when you can easily do that at a later stage and avoid the long wires getting in the way during the next steps. But you will also have to reduce some of that wiring because the panels needs to be mounted in the same slots where the wires were already tucked and hidden away. And the cherry on top was that one of the Z motor wires was too short. A lot of the time the manual just throws an exploded diagram at you instead of guiding you step by step like the VORON manuals do. That makes errors much more likely and often you have to reassemble things. Combine that with frequent mistakes in screw type and size and the whole process can get confusing. I ended up checking the CAD model frequently to make sure I was assembling the printer correctly. Fysetc did send a quick fix kit with all the missing parts, so it wasn't a long-term problem, but waiting 2 weeks to continue such a huge build is never fun. I tried to build Venture XL mostly stock, but I still had to make a few upgrades. First I replaced the hot end with Fysetc's Rapido 2 Ultra High Flow and a 0.6mm silicon carbide nozzle. Since it has a longer melt zone, I needed to print a new parts and lower the probe with spacers to maintain the offset. I also added a stronger cooling fan, insulated the bottom and sealed the air gaps. During the AB drive assembly, I designed and added double shear bearing support for the long motor shafts. Instead of using the included RGB strips, I went with high CRI LEDs mounted on aluminum profiles connected to a clipper expander board. I skipped the installation of a lighting strip under the X-axis to avoid dumping even more heat into the aluminum extrusion. This part already thermally expands the most since it constantly hovers above the heated bed. I also didn't install the Stealth Max filtration system due to limited space. So how does it perform? For full transparency, Fysetc provided the printer and paid for the video production, but this isn't a sponsored video. They had no input on the content and everything here is my own opinion. It got off to a rough start when the filament loading macro broke the pinion gear of the extruder's motor. Fysetc sent a replacement, and in the meantime I rewrote all the macros to my standards. One of the most useful is my bed heating macro, which powers each bed one at a time in 5 stages. You can blast full power to all beds at once, but considering how long prints will be, a UPS is highly recommended if power flickers, and UPS prices skyrocket the more powerful they need to be. With the power sorted, I checked the bed level. Each plate has spacers with springs inside. Initially I fully tightened them and got around a 0.5mm range of high and low points. After some tweaking I got it down to 0.17mm. So while it is a great result, I was way more interested in whenever this printer can lay down consistent first layers. To determine that, I printed squares across the entire bed and judged them by their look. A small deviation of nozzle being slightly too close or slightly too far from the bed is nothing to be worried about. But if we get high deviations like with these specific samples, well, that's not good because it can result in print coming loose or being very hard to remove. I played with different scanning speeds, but I feel like the good long heat soak of a printer made the biggest difference. Considering that this way I didn't have real issues with the first layers on my big prints, I would say the probe does the job for the most part. But I still had to adjust the Z offsets quite often, despite taking into account the thermal expansion of the hot end with different materials. Speaking of thermal expansion, because the plastic panels of the enclosure are cut to the exact frame size, they have little warp as they expand more than the metal frame. Even at 70°C bed temperature, panels start pulling away, forming air gaps. It is even worse with the doors, as you have to force them in hard to close. The enclosure feels more like an afterthought than a properly engineered design. Before big prints, I ran these stress tests: max flow, acceleration, cooling and extrusion consistency. During max flow testing, even with Raptor 2 ultra high flow, I reached 50 cubic millimeters per second, but great lay adhesion only held up to around 30 cubic millimeters per second flow rate, so imagine how limiting the stock hot end would be. There was no guidance on belt tensioning, so I went by feel from my experience. Input shaper tests suggested keeping accelerations below 3000 mm per second squared, which is quite good for a printer this size. The test print told a similar story, suggesting not to push the printer hard if you want quality prints. Still remember, smaller printers will always outperform larger ones in speed and quality due to basic physics. Bigger printers means more mass, more vibration and more smoothing, leading to lower quality prints. So only go big if you actually need it. Extrusion consistency was good, PLA cooling was average, similar to my smaller VORON, and no vertical fine artifacts, likely because of the long belts that dampen vibrations from my motors and overdrive components. With everything dialed in, I wanted a finishing touch, something like a badge, so I designed one and had it CNC machined from aluminum by today's video sponsor, PCBWay. It is a perfect time to do that as they started their 11th anniversary sale. It turned out great and represented well the trend of using aluminum for the most parts of the printer. I wish Fysetc included something similar, even smaller one, to mark the build completion. So let's finally print something big. Sunlook kindly provided the filaments and we'll need a lot of them. I started with their PTG to finish an older project. It is one of my favorite PTGs due to its strong lay adhesion. But I quickly realized this print, which wasn't even that big, used nearly a full 1 kg spool. So with big printers we are mainly limited by how much filament we have on that spool. By using standard 1 kg rolls, a lot of the time means choosing between tall and narrow prints or short and wide ones. I love wall decorations, so printing them big is an amazing option to have. On the other hand, printing tall things in vase mode gives you the ability to push a lot of plastic in very short time, considering how big the prints can be. But for strong, large, more regular prints you'll need at least 3 kg spools. The kit includes rollers for them, but ideally printing from a dry box like the Sunlook SP2 would be the way. Prints will be very long, so instead of applying constant heating, sealing the dried filament with some desiccant is the most cost-effective way. However, at these sizes a lot of models lose detail unless they are exported with high resolution. You will also want thicker walls. Thin shells on big prints can be very flimsy. So when we look at the final estimation, we can literally print one thing, no pun intended, with one 3 kg spool, which sounds kinda crazy. The print was going so well, but of course the PTFE tube had to tangle into the 3 kg spool and completely prevent filament from extruding. I wish the printer had filament movement sensor, not just runout sensor. Big failed prints are expensive, so risk mitigation is key. Luckily, this time it was easy to salvage the print by printing and gluing the fingertips plus some sanding. Next I tried Sunlook carbon fiber PTG with a Vanta vase model, but stringing and extrusion issues made me cancel the print. I experienced the same problems on another lighting project print. A reminder, if you're having trouble, it is probably slicer settings and not the printer or the filament. I lowered the flow rate, tweaked retraction settings, and the next print came out so much cleaner. I repeated the lighting project print using Sunlook's carbon fiber nylon to see how it handles big prints. Nylon shrinks way more than PLA or PETG, but after I let it fully cool off, the part had only slight warping, which is perfectly acceptable in this case. So what are my final thoughts on the Venture XL and large format 3D printing? The motion system and the frame of a Venture XL seem solid. Choices like genuine minimal power supplies, bed heaters with 3M high temperature adhesive, 9mm Gates belts, aluminum motion system parts, and even genuine Wago connectors are amazing to see. We even have a miniature circuit breaker that adds an additional protection for all components. It truly feels like they actually tried to provide quality components and not just cut costs. My main complaints about the mechanical side of things are no double bearing support for the AB motors, the weak stock hot end, and a poor enclosure design that warps very badly. There's also a concern about warping axes when we print enclosed, as aluminum extrusions and linear rails have different thermal expansion rates. Something like correct thickness titanium backers might be a solution. Most of these issues can be fixed by Fysetc in the future revisions without needing a full redesign and full reassembly of a current version printer, which is great, but the assembly manual really needs improvement. Too many errors, missing details, and confusing instructions. You need prior experience to navigate the build properly. Big 3D printers can burn through filament fast, but holding a gorgeous massive finished print feels almost real. The Venture XL opens up incredible possibilities if you truly need to print big stuff. Just keep in mind, it takes a long and challenging venture to get there. I hope this gave you a better idea what to expect from Venture XL and large format 3D printing in general. Thanks to everyone who supports my work on YouTube and Patreon. That's all for me, and we'll see you next time.